Good morning. Today in this video I have done total probability along with it Bayes theorem. These two are very important. So to explain total probability or totality theorem or total probability, I will explain this way. There are three boxes: box 1, box 2, box 3. In the first box, some screws are there. Among those screws, some defective screws are also there. Similarly, the second box and third box. So, in the first box, the defective screw probability is 1 by 3. Second box, defective screw probability is 1 by 5. And in third box, 1 by 6. 1 by 3, 1 by 5, 1 by 6. These three probabilities are the defective screw probabilities in the three boxes. Every box screws are there. Some defective also there. Like that in every box. The probability means the chances of having defective screws 1 by 3, 1 by 5, 1 by 6. Okay. The totality probability is the totality theorem or the theorem of probability, theorem of total probability. Theorem of total probability is, or some people will call totality theorem is, how many boxes are there? 3 boxes are there. So, each box probability is, each box chance is 1 by 3, 1 by 3, 1 by 3. So, you may keep your hand in first box or in second box or in third box. So, box probability is, box chance is 1 by 3. First box, if you want to select first box and keep your hand and take the screw, that selection of the box probability is how much? 1 by 3, because there are 3 boxes equally shared. So that is called selection of the box probability 1 by 3. So 1 by 3, 1 by 3, 1 by 3. Total how much? 1. 1 by 3 plus 1 by 3 plus 1 by 3 equals to 1. So that is called totality theorem. What is that 1? Sample space. So sample space has been divided into 1 by 3, 1 by 3, 1 by 3. And if you add all these 1 by 3, 1 by 3, 1 by 3, we will obtain 1. That is the maximum probability. That is, yes, sample space is 1. Okay, understood? So, this idea is involved in it. That is why this is called theorem of total probability. So, how to do the sum of this? What is the question? Matter I told. What is the question? I did not say the question. What is the question? Find the probability. At random, if you take from any box, that should be defective. The screw must be defective. The probability that the event that the screw must be defective. Whatever the box you select, we don't know. But the screw, you have picked up one screw, either of these three boxes, that should be defective. What is the chance for that screw to be defective? If you take from either from first box or from second box or from third box. That is the question. What is the probability that the screw will be defective whether you take from first or second or third box? That is the question. So for that, first sample space have been divided into three parts now. 1 by 3, 1 by 3, 1 by 3. That is called box selection probability now. Box selection probability 1 by 3 into what is defective screw probability I have given 1 by 3 plus, this is one case, plus means or, either or else, plus means or else, either or, like that we say. So here first one is box probability 1 by 3. Box probability means what? Selection of box probability. Selection of the box probability is 1 by 3. First box selection 1 by 3 into the defective screws probability in the first box is 1 by 3 plus means what? Or else. You may keep in the second box. You may keep your hand in the second box. No. So or else means what? Mathematically plus means or else plus 1 by 3. What is that? Selection of second box probability 1 by 3 into the defective screw probability I have given in the question 1 by 5 or else plus third box probability is 1 by 3 into 1 by 6. That's all. This is, if you find, you will get the answer. What is that? What is that series I told? 1 by 3 into 1 by 3 plus 1 by 3 into 1 by 5 plus 1 by 3 into 1 by 6. Selection of box probability 1 by 3 into defective in the first box screw. Defective screw probability in the first box plus means what? Or else second box probability, second box selection probability is 1 by 3 into, in the second box defective screw probability is 1 by 5 plus means or else third box selection probability is 1 by 3 into, in the third box defective screw probability is how much? 1 by 6. Like that I kept. Please calculate this. You will get some value that is giving us the probability or the chance of getting the screw defective either from any box. This is called totality theorem or theorem of total probability. Okay, the same thing I have explained in different with various illustrations in my book. I explained it. Please follow it. Next one. With the help of this, Bayes, the great person Bayes theorem means the theory of Bayes. What he said. A little change. With the same illustration, I will explain the Bayes idea, Bayes theorem, Bayes theory. Bayes theory means Bayes idea and Bayes view. on a particular thing. What is that particular thing? Suppose at random you select one screw, you will get the defective screw. Suppose you got the defective screw, what is the probability or the chance that the defective screw must be from the first box? Here the question is changed. Why the question is changed? Because the situations may be like that. Different situations will give different questions. So in case Bayes crossed this situation, defective screw at random we can select. So defective screw at random, it occurs that at random defective screw has come. But it should be from the second box or from the third box or from the first box. Let us say one thing. That defective screw must be from first box. The question is the probability that the defective screw must be from first box. The probability that or the chance that defective screw at random taken or drawn from the boxes, the box must have been first box. So he is giving a new question. Defective screw you have taken, okay, but the probability or the chance defective screw is drawn from first box. What is that probability? And then it is very easy. So the probability is defective screw from first box. First box 1/3. That is box selection probability. Box selection probability 1/3. That is the partition of sample space. So 1/3 into the first defective, the first box selection probability is 1/3 into the defective probability is 1/3. 1/3 into 1/3 whole by total probability. Just we have, before this we have calculated. No, the total probability you keep in denominator. Keep in denominator total probability. And in numerator, what you want to keep? You keep what is required. What is asked? What is asked? First box selection, defective screw. So first box selection is 1/3 into defective screw. Defective screw probability for the first box 1/3. First box selection probability 1/3 into defective screw in the first box probability is 1/3. 1/3 into 1/3 whole by totality. That is Bayes' view. When the question is asked in such a way that the defective screw is drawn and it should be from the first box. Suppose from the second box, and then second box probability is 1/3 into second box defective screw probability is 1/5. 1/3 into 1/5 whole by totality. That is Bayes. I have explained by giving one illustration which is very easier for everybody to understand. I have explained about totality and with it Bayes. Bayes idea, Bayes notion or theory of Bayes. When the question is in different style. What is the style? Defective screw, not only defective screw from the second box or from third box or from first box? That should be asked. Okay, understood? Understood? I think I tried and made you understand this. If you go through my notes and explanation, you can understand far better. Okay. For more updates, you never forget, share, subscribe, like, share, subscribe and click the bell icon. Don't recite these 4 words as a poem, because I am reciting every video. You will be also habituated to recite the same 4 words, not like that. Please share this, subscribe this and pass on this news to all of your friends and let them learn, you learn, and let them flourish and let them get the knowledge. Okay? So, please be helpful to share with others, to interact with others. And if you want to meet me personally, you can meet me at the college when I go to college classes. Okay? Any doubts or any comment or any clarification, comment box will be there, comment will be there, nearby video, nearby YouTube video, comment will be there. You can put there, you can tell your comment, I will clarify it, I will answer it. Okay, thank you. Please, without wasting time, go through my notes and my explanation. Try to understand. If you do not understand, 2 to 3 times you watch the video and you will have it. Definitely you will understand it. Thank you for your cooperation. Thank you so much. Dear students, theorem of total probability, partition of a sample space. This is sample space, yes. I have plotted the sample space E1, E2, E3, E4, so on, like this, En. A is one set. A is an one event. Associated with this sample space. A is one event associated with this sample space. Let E1, E2, E3, so on, En be a partition of sample space S, and suppose that each of the events E1, E2, so on, En has a non-zero probability of occurrence. Let A be any event associated with S, then P of A equals to P of E1 into P of A on E1 P of E1 into P of A on E1 P of E1 into P of A. This is A, no? This is A, no? P of A on E1 P of E1 into P of A on E1 plus P of E2 into P of A on E2, like that. So on P of En, P of A on En, like this. The total, this is totality, this is total probability is nothing but P of A, P of A. P of A means this. The probability of this event, can be taken as P of E1 into P of A on E1, P of E2 into P of A on E2, like that. P of E3, P of A on E3, so on P of En, P of A on En. Totally, this will give you P of A. P of A means A be the event, the probability of that event P of A. A be the event, probability of this event A. We can obtain like this. This is called, in sigma notation, J equal to 1 to N P of Ej into P of A on Ej. Both are same. This is called Totality Theorem or total probability. By this figure you can understand. Proof we can easily do, because sometimes for board exams or 12th class exams in CBSE exams, NCERT exams or intermediate exams, they may ask you proof sometimes. That is why this may be useful. By learning this proof, you can understand some sequences and some idea. You will have some ideas while doing some sums for the competitive exams also. A equals to A intersection yes. You see here? A equals to, this is total yes. This is A. What is the intersection? A only. A equals to A intersection yes. A intersection yes means, what is yes I told? Here I told, what is yes? Yes has been partitioned, or yes has been parted. E1, E2, E3, E4, E5, E6, En, like that. All I have parted. Total yes has been parted like that. So I have given like this. What is yes? E1 union E2 union E3 union so on union En. So A equals to A intersection E1 union A intersection E2 union, so on like this, according to set theory. P, I apply P both sides, probability of A equals to probability of this and plus probability of this plus probability of this. So probability of A intersection even from the conditional probability we got this by cross multiplication, we got the multiplication theorem. Remember multiplication theorem, before this you learned it. P of A intersection E1 equals to P of E1 into P of A on E1 plus P of A intersection E2, P of E2 into P of A on E2 plus so on. This is called P of A. P of A equals to, with sigma notation, sigma from J equals to 1 to N, P of EJ into P of A on EJ. This is theorem of total probability. By this you can understand, and the proof also you learned it. I will explain by giving this illus means illustration for better understanding of total probability theorem. The chances of defective screws in 3 boxes. The chances of defective screws in 3 boxes are 1 by 5, 1 by 6, 1 by 7 respectively. Then the chance of the event that a screw selected at random is defective. Observe this question. I am keeping the question stays for a few seconds. Here, the chances of defective screws in 3 boxes are 1 by 5, 1 by 6, 1 by 7 respectively. Then the chance of the event that a screw selected at random is defective. Theory of total probability. Theory of total probability, S equals to 1 by 3, 1 by 3, 1 by 3 equals to 1. What is this 1 by 3? 3 boxes. Selection of 3 boxes. First box, 1 by 3 ways we can select. Second box, 1 by 3 ways we can select. Third box, 1 by 3 ways we can select. So 1 by 3 plus 1 by 3 plus 1 by 3, it is 1. It is totality theory. That is sample space S equals to box 1 union box 2 union B3. P of S equals to P of B1 plus P of B2 plus P of B3 equals to 1. A required probability P of A equals to first box selection probability P of B1 into P of A on B1. Okay, P of B1 is selection of the first box probability into P of A on B1 means defective screw probability in the B1 box. Plus means or else another way, P of B2 selection of the second box is 1 by 3 into P of A on B2 means defective screw selection, defective screw at random in the second box. P of B3 into P of A on B3. So 1 by 3 selection of box probability, and 1 by 5 is defective screw in box 1, plus means or else 1 by 3 second box probability, second box selection probability into 1 by 6 is in the second box defective screw probability, plus means or else third box selection probability into 1 by 7 is defective screws probability in the third box. That is called 107 by 630, that is P of A. This is called total probability. The question may be given like this, total probability, and you can understand like this. On total probability, another question. A person has undertaken a construction job. A person has undertaken a construction job. The probabilities are 0.65 that there will be strike, 0.80 that the job will be completed on time if there is no strike, and 0.32 the job will be completed if there is strike. Then probability that construction will be completed on time is a person has undertaken a construction job. The probabilities are 0.65 that there will be a strike. Strike probability 0.65. So non-strike probability 0.35. 0.65 is strike probability, non-strike probability 0.35, because the total will be 1, no. The total will be 1. 0.65 plus 0.35 equals to 1, no. That is sample space, no. That is sample space. Strike probability will be strike 0.65. And non-strike, no strike probability 0.35. That is, I have taken like this, S equal to B union B dash. Let B event strike, B dash event no strike. Total 1. P of B 0.65 given, P of B dash no strike probability 0.35, we can put. It is given, but we can say like this, no. If strike probability is given, non-strike probability 0.35, we can tell no. That is P of B 0.65, P of B dash equal 0.35. P of A and B. A and B means the job will be, let A that job will be finished. Let A that job will be finished. So P of A and B, it is given, you see here, 0.80 that the job will be completed on time if there is no strike. No strike, the job will be finished probability. The finishing job probability is 0.8. 0.8. When there is no strike. No strike means B dash. 0.8. 0.32, the job will be completed if there is strike. So there is strike. A on B. A means completion, about completion of the work. A on B means strike 0.32. So 0.32, that job will be completed if there is strike. So P of A on B, B means strike. On strike, the work will be finished 0.32 probability. Without no strike, on no strike, the work will be completed. The probability is 0.80, 0.80, 0.80, 0.80. The probabilities over the probabilities over 0.65 that there will be strike. 0.80 that the job will be completed on time if there is no strike. If there is no strike, the job will be completed, probability is 0.80. Let A, that job will be finished. P of A equals to P of B, P of A on B plus P of B dash, P of A on B dash. This is totality theorem. This is total probability. 0.65 into 0.32 plus 0.35, no strike, 0.80. If you simplify this, 0.488 P of A. So P of A equals to 0.488. Please observe this question. Okay. The probability that, see another illustration for totality theorem. The probability that certain electronic component fails when first used is 0.10. So working capacity of the electronic component probability is 0.10. 0.10 is working capacity probability. So this is P of F 0.10 working capacity probability. Then P of F dash 0.90, because 0.90, 0.10 total 1. This is 1. This is sample space has been divided into two parts. One is working capacity probability 0.10 and another is not working capacity probability 0.90. This is fails when first use the 0 point component fails. means 0.10 is fails working probability. This is working probability. 0.90 it will work. 0.10 it fails to work. You see, component fails when first used is 0.10. So working capacity probability, failing probability 0.10, and lasting is 0. This is working capacity f dash. This will not fail to work 0.90. Okay, now lasting is if it does not fail immediately, the probability that it lasts for 1 year. So lasting probability is 0.99. If it does not fail immediately, the probability that it lasts for 1 year is 0.99. So this is lasting probability. Lasting probability means the component lasts for 1 year. That probability 0.99 is calculated by the company. Find the probability that a new component will last for 1 year. If the same type of component, if you want to take for 1 year durability, for 1 year lasting, what is the probability of 1 year lasting? What is the probability of 1 year lasting of that new component, of the same new component? What is the probability of lasting for 1 year the same new component that is the question. So here, fails to work, working probability 0.10, and this is lasting probability, immediately fails, no, immediately it fails. So this is what? Lasting probability 0. This is working probability 0.10, lasting probability 0, and working probability 0.90. We have taken this one, and this is given in the question. This is lasting probability 0.99, like this. Same type of question, same idea of the question, but the question is different, but the idea is same. So if you calculate P of E equals to 0.891, it means this is the chance that electronic component will last for 1 year. This is the chance, or this is the probability. 0.891 probability may be there that electronic component will last for 1 year. Bayes' theorem. This Bayes' theorem is in connection with total probability theorem. The total probability you can keep in denominator place. This is total probability. This total probability you have kept in denominator place. And in numerator place, which is requirement, the requirement of probability you will keep in numerator place. And total probability you have to keep in denominator place. So, in following totality theorem, following total probability, Bayes is created. Bayes is created following total probability. You see here, if E1, E2, E3, so on, En or N non-empty events which constitute a partition of a sample space, yes. Total probability, I don't know that one only. That is E1, E2, so on, En, or pairwise disjoint, and E1 union E2 union E3 union so on union En equal to S, and A is any event of non-zero probability, then A is associated with the sample space. In total probability I explained with Venn diagram. Then P of EI on A equals to P of EI into P of A on EI whole by sigma j equal to 1 to n P of EJ into P of A on EJ. The denominator part is nothing but total probability. You have learned already before this. Dear students, Bayes' theorem, most of the times the proof of Bayes' theorem, most times asked in intermediate question paper, board question paper, in second year board question paper, and also CBSE papers also in 12th class exams. So that is why proof also I have given. Very simply you can write proof like this. By conditional probability, P of EI on A equals to P of A intersection EI by P of A. That you know very well. P of EI into P of E on EI in place of P of A intersection EI, in place of that I have written, this is called by multiplication rule. You have to write, you have to mention these things. You write like this, by P of A. So P of EI, P of A on EI, multiplication rule this is, whole by P of A can be written like this. This is totality theorem by theorem of total probability. Before this you learned, that is given this one. Like this, by mentioning and referring this one and this one, you can write the proof like this. These steps, you will get 4 marks. Differences you have to write by conditional probability, by multiplication rule, by theorem of total probability, like that. Otherwise it is not impressed. Let us see. Bag 1 contains 3 red balls, 4 black balls. Bag 2 contains 5 red balls, 6 black balls. One ball is drawn at random from one of the bags and it is found to be red. Then probability that it was drawn from bag 2. So from bag 2 the red ball must be drawn. That is the question. That is requirement. Red from the second bag. Red from the second bag. How many bags are there? 2 bags. So bag selection probability is 1 by 2 into from the second bag selection probability is 1 by 2 into second bag red ball probability is 5 by 11. 5 by total balls 11. So 5 by 11 whole by totality theorem. 1 by 2 into 5 by 11. Another one, first box selection probability 1 by 2 into first box red probability. First box red, 3 red, 4 black. So 3 by 7. So 3 by 7. What is the question? Second box should be second box and red. This is red ball probability and this is second box probability. 1 by 2 into 5 by 11. This is first box probability and first box red probability plus second box probability, second box red probability. This is total probability. And requirement is the red ball must be coming from second box, second bag. That is given. Founded. Then the probability that it was drawn from bag 2. If we calculate 35 by 68, this is BAYES question. On BAYES, another question, please observe. A doctor is to visit a patient. From the past experience, it's known that the probabilities that he will come by train, bus, scooter, or by other means of transport or respectively. So transport probability 3 by 10, 1 by 5, 1 by 10 and 2 by 5. Train probability 3 by 10. Bus probability 1 by 5. Scooter probability 1 by 10. Other means of transport 2 by 5. So by these chances, the doctor uses to come to visit the patient. The probabilities that he will be late, so late coming probability or 1 by 4. 1 by 4 means what? By train 1 by 4, by bus late coming probability 1 by 3, by scooter late coming probability 1 by 12. If he comes by train, bus, scooter respectively. But if he comes by the means of other transport, then he will not be late. Other transport probability 1 by 12. But coming not late, coming in time only by other transport. When he arrives, he is late. What is the probability that he comes by train? When he arrives, he is late. So, what is the probability that he comes by train? So, what is the requirement? Late probability into train probability you have to keep. Okay? See here. Here, train probability how much? Train probability 3 by 10. 3 by 10 into by train late probability coming late 1 by 4. We have to keep in numerator because it is the requirement. The doctor is late and that too is by train. So this is, you have to keep. Below it, in denominator, total probability. Total probability you write 3 by 10 into 1 by 4 plus 1 by 5 into 1 by 3 plus 1 by 10 into 1 by 12. 1 by 10 is transport probability. 1 by 12 is late probability. Plus other transport probability 2 by 5. So you will not come late. No late probability. So 2 by 5 into no late probability is 0. Like this we keep. This is the requirement and this is total probability we keep here. So equals to 1 by 2. After simplification we will get the answer. Please observe once here. Transport chances 3 by 10 plus 1 by 5 plus 1 by 10 plus 2 by 5. It is 1. It is yes. So that is called totality. If it indicates theory of total probability, it indicates theory of total probability. P of T1 is 3 by 10, transport 1. P of T2 is 1 by 5. P of T3 is 1 by 10. P of T4 is 2 by 5. These are the transport probability. P of E on T1, the chance that the doctor arrive late by train. So, late coming probability, P of E on T1 is 1 by 4. Late coming probability, P of E on T2 is 1 by 3. P of E on T3 is 1 by 12. P of E on T4, other means of transport, late coming probability 0. That's all. Like that, we have cut. This is Bayes application. A man is known to speak truth 3 out of 4 times. A man is known to speak truth 3 out of 4 times. So 3 by 4 truth probability, 1 by 4 false probability. Total 3 by 4 plus 1 by 4, how much? 1. This is total probability. He throws a die and reports that it is a 6. He throws a die and reports that it is a 6. Then the probability that it is actually a 6. To come up 6, 1 by 6 probability. So here, what is the question? Actually 6 has come up. The person has told truth only. So truth probability into 1 by 6. You see here, truth probability is 3 by 4 into 1 by 6. This is truth probability, and this is on die, throwing a die, turning up 6 number on the face. The probability is 1 by 6. So he spoke truth. Therefore, this is truth probability 3 by 4. You see, speak truth 3 out of 4 times, 3 by 4. So 3 by 4 into 1 by 6 whole by 3 by 4 into total probability 3 by 4 into 1 by 6 plus 3 by 4. In the sample space, what is left? False. False 1 by 4. No. 1 by 4 into 5 by 6. This is 1 by 6 is exactly number 6 comes up into truth probability, or else false probability does not speak truth into 6 has not come. 6 has not come up. Other numbers has come up. That is 5 by 6. False into 5 by 6 probability. So this is total probability we keep in BAYES. And the requirement is truth, he said. It has come up 6 number on the face, and he said same 6 as a truth. So 3 by 4 truth probability into 1 by 6 whole by 3 by 4 into 1 by 6 plus 1 by 4 into 5 by 6. Total required probability is 3 by 8. Please observe once. Probability to speak truth P of T 3 by 4. To speak false P of F, P of T dash. This is P of T. Speak false. P of false means P of F. P of T dash equals to 1 by 4. This is 3 by 4 plus 1 by 4. 3 by 4 plus 1 by 4, how much? 1. That is yes, sample space. So totality theorem is included in BAYES. Probability that 6 occurs, P of E equals to 1 by 6. 6 does not occur, P of E dash equal to 5 by 6. Therefore, P of E on T equals to E on T means coming up 6, telling truth. E on T equals to P of T on E into P of E whole by P of T on E into P of E plus P of T dash on E dash into P of E dash. That is 3 by 4 into 1 by 6. 3 by 4 into 1 by 6 plus 1 by 4 into 5 by 6. Required probability is 3 by 8. Like this, we can explain Bayes with some illustrations. Model wise I explained, but you have to do, with the basis of this, you have to do more exercise from the NCERT textbook, 12th class, under the chapter Probability, Bayes theorem and Totality theorem. Please do exercise, then only you will have the best returns and result. Thank you.